Here's a nightmare scenario. The number one reason why the distributed systems are hired by the FAANG and the big tech company is that suppose it's 3 a.m. and the leader node crashes and there are 10 million users who's trying to access the data. What happens now? There can be multiple scenarios of failure. Let me take each one of them one by one. So first scenario can be a follower failover. In a follower failover, the follower fails. So let me draw this for you. We have a system that is the leader, then we have followers. Now, suppose this follower fails. What happens is the read goes to the other follower. So in this case, the read, instead of going to this follower, it doesn't goes anymore to this, it goes to the other followers now. Now there can be a scenario 2 as well where the leader crashes. In this case, it is called a failover. Let me draw the arrow for you. In this case, the leader fails and we can remove the... So there are a couple of steps which we do for a leader failure. First is detecting the failover. In this scenario, the followers notice that the leader hasn't sent any data for 30 seconds. So even if there is no data from the client, the leader keeps on sending a heartbeat kind of data every few seconds to all the followers. And in this case, if the threshold is 30 seconds, then it is assumed that the leader is dead. Step 2, we choose a new leader. In this case, all the followers, after deciding that the leader is dead or not available anymore, they choose a new leader. There can be 3 types in this case. The first one is election process. The second case can be the manual process. And the third can be pre-configured controller nodes. So in an election process, the followers decides a new leader among themselves. This can be used by doing a Raft algorithm, or Zookeeper does the same. Then a manual process is like intervention by an administrator. This process is a bit risky and slow. In the pre-configured controller nodes, it decides which node to be put as a new leader. After step 2, we do step 3, in which we promote a follower to the new leader. So what happens is, once the leader has failed, out of all these followers, we have a new leader. So this is the new leader. So this becomes... Then we have step 4, where we reconfigure the systems. In this step, the client needs to send the new writes to the new leader. This is often done through a load balancer or a service discovery like Consul or etcd. So the client now, instead of sending to the leader, which was the old leader, now it sends to the new leader. All the requests are directed to the new leader. Okay. There can be certain critical challenges which can come up with the election process. So let me put that for you. One we can have is that there can be a data loss. So whenever a new leader is elected, there might be a chance that the follower doesn't have the leader's data and it hasn't yet been replicated. In that case, there is a data loss. Another is split brain. What if the old leader comes back online and thinks it is still a new leader? Now there are 2 leaders. So that is why there can be a data corruption. So this scenario is called split brain. To solve this solution, we can use a technique called fencing. So whenever the old leader is forcefully coming up and deciding it to be a new leader, it is forcefully shut down. Third can be a timeout settings. If the timeout setting is too short, then there can be false alarms or unnecessary failovers. And if it is too long, then there can be a long downtime. So these are some of the challenges which we face during the failover scenario. You can always mention about consensus algorithm like Raft and Paxos to elect the leaders safely. This shows a staff level or a principal level thinking.